Okay, we are now going live, and today it's not just a test stream, it's a stream where we're gonna do something more practical, I guess, and that is to write a bunch of payloads in C. So I want to test my system, how it behaves, how does it work, and so on. And yeah, I think we're gonna have a little bit of fun. Now, first I want to make sure that all my adapters are the same. So as you can see, we have breached adapter here, breach to specific name, which is WLO1 because I'm connected to the Wi-Fi. And essentially we're gonna need this to be breached for both of the VMs, otherwise they will not be able to talk to each other and pretty much do anything. Right. So now we're gonna open the Kali VM, which we're gonna actually use as a server. So I would not need that to be full screen, but rather that, yeah, exactly. Here, if you find any issues at some point, I'm also doing that on Discord on my server, so make sure to join. If you find any issues with the stream, just make sure to hit me up. Yeah. So I'm gonna move that to here, and that to there, and that to here. Okay. What happened now? Okay. Okay. Now I want to be that window to be here, that to be here. Now like that. And here is the Kali. And here is gonna be the Windows. Come on. Yeah, there it is. And here is gonna be the Windows VM. Again, I don't want full screen. That's fine. So I can switch easily with from VMs and so on. Yeah, there it is. Boom, 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 boom. Okay, I think we can do something like that. Can we resize the window? No. Why that happens now? Is it because I deleted the ISO file? I think that's highly possible. Even though the copy paste works. Ah, there it is. Okay, it needed some time. Okay, perfect. Here. I did not change the default password so far. Ah, I don't like that. There it is. See the wallpaper. The new Kali wallpapers are nice, chat. I really like them. What do you think about it? I enjoy them so much, especially that one. Okay, so here we're gonna use Kali for our infrastructure. We're gonna host things on it because right now it's empty, nothing's there. So first I'm gonna do passwd to change my password. Okay. Yeah, okay. Okay. I think everything is fine now. If you experience any issues, just let me know. Okay. Now, what we want to install is generally, I think Mythic should be fine. Yeah, I think Mythic should be fine. I'm gonna also do performance mode, just why not? And I think doing Mythic should be fine. What do you think, chat? Mythic or Havoc? Let's do Mythic. I think Mythic is fine. I'm gonna open a browser, go to Mythic C2, and let's set up everything from scratch. I think that can be super useful for the stream and to see how everything is being set up from the very, very bottom zero. So usually when you want to install Mythic, you want to obviously clone the repo, so sudo git clone and paste. Now I'm gonna use opt as a folder, but it's not 100% needed, so I don't mind if the opt is not the option. It's definitely no problem at all. On the Windows side, I think on the Windows we're good because in the Windows we have Visual Studio. I think, yeah, we have. So with Visual Studio up and running, I don't think we're gonna need anything else beside that. So we can code on VS, we can pretty much do anything. We have C, I think we have C, let's see. We have C? Let's see. Okay, console app, that's C sharp. Console app, that's post, yeah, there it is. There it is, we good, we fine chat, we good. Okay, let's go back. Now, from here, let me check the pan. Okay, good. Now, from there, yeah, we need make. Do we have GCC? No. Yes, we have also make, which is fine. So we're gonna go to Mythic, and now here do sudo. Yeah, first we need to do sudo install Docker Kali. And that's going to install the Docker and Docker Compose plugin because that's needed. And I debugged way too much time for knowing that we would need not only Docker but Docker Compose also. So that's pretty much important. On the Windows, I don't think anything else we're gonna need, so that's fine. So don't mind that. Here, okay, if you have questions in the meanwhile, you can do it in the chat or hop into the Red Team in Army Discord and ask it there. So that's the options. Yeah, so here we're gonna looks like the update is now fixed because in the past this file was not working because I spoke with the Mythic creator, one of them, and he mentioned that it's actually Kali sometimes bug things out and they place a bunch of packets. So Docker Compose was not available at the time. You need to do some kind of tweaks to get it, but now I think it's good. So what we can do now is do sudo make, and when doing sudo make, it's gonna pull everything, and at the end we're gonna have that Mythic CLI thing where we can engage with Mythic. So we can do sudo and then do Mythic CLI, and it's fine. Now here we're gonna need to add C2 profiles. So Mythic C2 profiles, and this is pretty much how we want to communicate with Mythic. Yeah, there's a bunch of documentation. That's why I like so much Mythic, and not only for that, but that's one of the reasons. So there's a good documentation that can help you with most of the stuff. And here we can choose what type of connection we would need for the Mythic C2. So when we start the agent from the Windows VM, as soon as we start the agent here, how that agent is gonna communicate with the Mythic via which protocol. Now, usually I enjoy Discord so much. We also did a workshop in Sofia for B-Sides, and I showcased how OP that is, and it's super hard to be traced because Discord is doing its own load balancing and things like that. So if you have Discord allowed in your environment and organization, please remove it. You don't need it. Trust me, you don't need it. Then I didn't try DNS so far. There's also GitHub, but the GitHub and the Discord are only for Athena. And now I don't think we want Athena because Athena is generally a .NET Core based, and I think the whole execution part will be a little bit more complex there. So we want something like Apple for now, and let's go for the plain old good HTTP. So copy the link, go to the sudo Mythic CLI, install GitHub, and just paste. That's gonna install the HTTP container, and it's fine. Then we're gonna also need to have the agent, which in that case is gonna be the Apple. So here we pretty much do the same thing and just replace the URL with the one with Apple. So replace. Here we can generate a simple app. Go to C++, go to next, and let's go that stageless. Let's first do stages, guys, because I think it's more simple to do it. Yeah, create that. Okay, now here we have everything we need, and we can do Mythic CLI start, which is gonna boot everything up. Yeah. Now, generally, what I mean by staged and stages payload is as follows. So, where is that? Where is that? I'm gonna stop my screen share just for a second. Be right back. Okay, we are back now. And now, what I mean by stage and stages. Now imagine the following thing. That's the Kali machine right here. That's the command do right there. Right. Now, we got along that the payload's gonna go over HTTP. So the connection is gonna initiate from the command do to the Kali. So we're gonna do a reverse connection to the Kali itself. Okay, but it's gonna be over HTTP. Okay. And now the point is if it's staged or stageless. In a nutshell, what we want to do is staged. Because stageless is the following. The connection is going to originate from a process, right? It's not going to come from the air. So the connection is going to come from a process. This can be upload.exe, or it can be something like maybe stageless.exe or DLL side loading or anything in between. Doesn't really matter. But the connection is gonna come from a process. So the commando or the victim would need to somehow start a process, and then this process is gonna connect directly to the Kali machine, giving us callback. And from time interval, depending on the time set, then it's gonna connect more and give us the callback interval in seconds and whoop that thing. Okay, now that's a stageless part, and the thing here is that everything is inside the paywall itself. That's it. So the binary we drop has the final payload. It can be encrypted, it can be not, but it has the full payload. So we execute, the payload is there, and we have just one connection, which is the callback one, and that's it. Whereas with stageless, we have a slightly different scenario. Now here, let me write that to be direct callback. Now we have the same thing. We have the commando and some form for process because the connection must come from anywhere. And now the first request, by the way, first connection is not direct callback, but we have one read the payload. Then the payload is gonna be read from the remote server. Then it's gonna be dynamically allocated into the memory, and then we have a connection 2, which is gonna be callback. So here we have just one initial request, which is the callback itself, and here we have first reading the payload part and then doing the callback after the payload is read. Now generally, always we want to do something like a stageless communication. Staged, sorry. Because when you do staged, then just by staging the payload, you reduce the chance of it getting discarded by a lot of percents. Of course, this may vary on specific vendor and specific environment, but generally speaking, staged payloads are always better than the stageless ones. That's always the case. Now, to make things first simple, I want to generate a super simple payload. So we're gonna go to Kali. We're not gonna dive into Mythic yet. So here I'm gonna go to desktop and use MSF Venom. So MSF Venom -P Windows x64, and here we have to define staged and stageless. So if you do things like, let's do Windows, actually, what was it? Reverse TCP? Nah. Windows x64. What was, I totally forgot the name of that. Windows, yeah, that should be it. That should be it. Windows x64 reverse TCP. Yeah. Oh yeah, Windows shell reverse TCP. Yeah, that's it. Shell reverse TCP. Yeah. So now when you do it like that, and of course set up your options, host to be ETH0, port let's do 4444. Yeah, why not? And format let's do C, and output to be stageves.c. That's how you generate a stageves payload in MSF Venom. So when you have that underscore part, the payload is stageves, and as you can see 460 bytes are allocated. So I can cat stageves.c, and as you can see that's the full payload. So if I use that in some form of shellcode execution, then I can get the shell with netcat or with MSF console because the full payload is there. So let me showcase that to you. If I go here and do that stageves, the same, yeah, exactly the same one, we can first go to the solution explorer and make sure to rename that to C. So rename stageves.cpp to C. Do it like that. Then on the main, remove that. Then we also don't need that. Now here I can do include stdio.h, include windows.h, and now here define the payload. So paste, and that's it. And here we can do something like what was it? Pivot addr equals virtual alloc. Let's do AOP address. That's gonna be no. Then we have size. We do size of both. Then we have allocation type that we want to be memcommit and memreserve. And we also want to have the protection settings, which are gonna be page and then page execute read write. Yeah, we're gonna do the full memory permissions. We're not gonna bother about doing OPSEC things now. Then we want to copy that payload to the memory because now it's just a variable in our code, but it's not written into the memory of the process itself. Right, it's just a variable which is a hex string. And now we need to write that to the memory because we want to execute it. Now, generally speaking, shellcodes like that are machine instructions in hex. So we have that instructions, and in order for us to get it, because that's at the end a machine language, and in order for us to get it, it's represented in hex. So all that hex value must be written to the memory of the process, aka of the machine, and then it can be executed from there. So we can do something like memcopy and do things like destination. So that's gonna be source is gonna be, oh yeah, destination is gonna be a DDR. Then the source is gonna be the pop, and then the size is gonna be size of pop again. Okay. And now at the last we can simply execute it because we already have all the permissions we need. And here we can do something like, I don't remember the syntax. I need to look it up. So Marv development. That one. and that one. There's no way I'm getting that one correct. So here, paste, and that should be it. Okay. Now if I compile that, let's see if it's first gonna compile without a problem. I'm gonna save, switch to release, and compile as 64. Okay. Now I can simply try to execute it. Do I have CMDR? I think so. So open file location. Now from here, pin to taskbar. And do it like that. And open CMDR. There it is. Now I can directly execute it like that. And now before executing it, I want of course set up my listener, so I can do ncmdop 444, because that's the same port we defined in the beginning where we generated the payload, like here in this command. And now from there, I can try to run this command. I have a defender on the command VM. How is that even possible, guys? How is that even possible, chat? Hey, how you doing, mate? Isn't that in the GP settings? I don't get it. I also don't get it. But never mind. Now it stopped, so I can run it. And it was deleted by the Defender. So I can compile it again and rerun it. The shell hangs, which is generally a good thing. And here we have a callback. Now the reason why we have a callback and why we can access the commando is simply because we need some payload for bypass Windows security. Yeah, I know, but now the topic is slightly different. That's why I'm sticking to basic. And now here, the reason why that works with Netcat is because, as mentioned, the whole payload itself was into the binary. So that shellcode you saw there, that payload, that's the full payload the reverse shell needs, the full thing. And now the full thing is inside the binary. Now, of course, if you want to evade it, you can do things like encryption and staging, because staging is one of the most, I can say, stealthiest techniques. So I enjoy staging. And now the full buffer is here, the full payload is there, and that's why we can cache the shell with Netcat. Because it's compatible with Netcat, first, the whole shell payload, which is Windows x64 shell reverse TCP, is compatible with Netcat, and it's stageless. Okay, if we generate a staged payload, we would not be able to catch it with Netcat. Because if I want to try to do it, so here I can do shell and here do /reverse TCP, which is gonna be staged. Now if I try the same code with the staged payload, it's gonna fail. And I can try stage.c. I don't know why reverse shell is bigger, staged is bigger than stageless, but I don't care. So if I paste the same code there, the stage now, and if I compile that and rerun the same binary, while I have my listener running here, now it's not gonna work. See, we have some kind of connection, but in that case, this connection is designed to read the binary and not to directly give us a shell. So it wants to see the payload as a result and then to execute it and give us a callback. And that's why in this case it fails. Now if we do the same thing via Metasploit would know how to store the payload that the binary needs, and then if it's read, it's going to be executed. One cool thing we can do, one cool trick, is to set up a Python server. So Python 3 -m HTTP server and 444. And now from here execute exactly the same binary and see what it wants for. As you can see, we have some kind of strange requests. It's not even a request, it's an exception, because it looks like the reverse TCP is not requesting the shellcode from HTTP, but rather than from other TCP file communication process. Yeah, so it's not HTTP. Now in that case, the only way we can execute that is by using MSF console. So sudo MSF console. Now here we can specify use exploit multi-handler, because at the end we want to receive communication. Now set payload to be exactly the same, so Windows x64 shell slash reverse TCP. So remember, the slash is staged, whereas this is stageless. So that's stage 1. And now from there, do set lhost to be th0, set lport to be 4444, run that, and now it's gonna start a TCP listener. So it's not HTTP, but it's a TCP listener. As you can see, started a reverse TCP handler. So the payload uses some kind of a TCP communication to get the final bytes of the payload, but I was expecting it to be HTTP, but it's not. Never mind. Now when we execute it, we can first see that sending stage to the machine, and then we have a session opened. So that's the difference between staged and stageless, because in the stageless we're gonna directly get a connection back, whereas in the staged, the payload reached to us, we give him something to add extra or to complete the final bytes in the final payloads, then they are allocated to memory, executed, and then the final payload gives us a callback. If you want to graphically visualize that, it happens something like that. So it first reads the payload, we send the sending stage as Metasploit says, and then we have the callback. That's cool, but now let's do that a little bit more manual so we know what happens. And now if you go to offensive cpost cpp in my GitHub repo, you can see invasion staging techniques. You can see a bunch of them. So we have ADS stage, which is gonna use alternative data stream, which is super nice and a little bit stealthier. Then we have 3 main options. We have local stage, which is doing a pretty good job. Local stage means this is going to be staged as in a file. So we need to send the payload in the local file, and the payload would read the bytes from the local file. Or the payload can manually download the local file and then read the bytes from it. That's also a thing. Then we have HTTP stage, which is going to use HTTP/S to perform the staging part via HTTP. And we have also socket staging, which is going to perform the same thing via sockets. So we have a bunch of options, and I kind of enjoy the SMB one because there it is. I kind of enjoy the SMB one because usually when it comes to internal networks, and not only, there's an SMB traffic going on, and if you find the external SMB traffic, which is not that uncommon by the way, you can also use this kind of staging, because usually all the measurements are about HTTP and what happens over it. But if you can go over different protocol like SMB, it's even better. So staging via SMB is, I can say, super nice. Yeah, now this code is very simple. It has one function which is read bin, and this function actually reads a file from a remote share, which is gonna actually perform the staging, because we're gonna create a request to the server, reading the file from its share, and then executing that, and after this one, a new connection is gonna be made. So we can test that with Mythic, and let me first generate a payload. So I can exit that. I can go to HTTPS 7443. Save that. Now do mythic admin, cd opt, cd mythic and cat env, and get my password. I don't mind leaking that on stream because it's walkable either way. So paste, and now we're here. Now on the mythic c2, we can go to the payloads, and now first let me check if everything works. It is. Now by default the HTTP profile uses port 80 for communication and raw HTTP. If you want to change that, you can go to cd install services, then HTTP, then HTTP again, then c2 code, and here you have a config.json. In this config.json you can do change the port, you can change use SSL, and essentially you can even specify the key and the server path. Also, you can change the server headers. So, of course, if you have Mythic exported and to the external web, always change that. Just a nice advice. Yeah. So I'm not gonna do it now because I don't need to. But the whole thing is super simple. As mentioned, change the port, change the use SSL, and maybe the server headers, and that's it. So we don't need that for now. Now the profile works. I think you can also do it from there. So you can click here and maybe, nah, not here, maybe here. I don't know. Yeah, never mind. I also like to have saved instances, so I can do things like HTTP. Oh, instance name. Wait, that's gonna be 80. Like that, because I would know if I see that instance, I would know it's going to be on that IP, which I have now, and the port 80. Now I can pretty much copy the IP, which is going to be here, remove the S, change the callback interval because I want that to be shorter. The callback port is fine. I don't want this to be modified for now, we don't need it, and I can do create. Now let's generate a payload. I can go to actions and new payload, then next, then Apu. Then the default are pretty much fine. Then I can for now exclude all the commands rather than the word command. Like that. Next. Then I wanna go to my safety instance like that. See how easy it is. Boom. And I can click next. Wait. Windows. Apple. And we need shellcode. Yeah, that was super important. Because if we want it to be an exe, we would need to run download to get it to shellcode, but now it's going to be done automatically, so shellcode is fine. Then everything stays the same, like that. Go next, and here we need to change the apple.exe to bin. Create payload, and that's it. Now we have to wait a little bit for the payload to be finished, and while that happens, we're gonna go to the offensive C++ and copy the staging part, the whole code. So I'm gonna go to my command here, go here, let's open the, let me remove that, yeah, the same old payload, and I'll do a new project which is gonna be staged. So console app, staged, create, because it's good to stay organized. I think that's super important. Did I click create? I didn't. Okay, there it is. Now here again, change that to C. Now paste. Boom, and there it is. Now we need to tweak a bunch of things. We need to tweak the buffer size, and the buffer size can be retrieved from the payload itself. So I can download the payload. You can see it's 2 megabytes, but how exactly fat it is, we can go to downloads and do ls-la, and that's the final size. So we can get the final size and paste it there. And I always like to have one up, so it's a 49 at the end. We can do 50 because I always want to have 1 byte extra in emergencies, because in the past sometimes some techniques fail because of that byte. At least that's what I think. Now we have the buffer, we adjusted the size of it. Now it's empty. Ideally you wanna do it dynamic, So without static allocation, you can do dynamic allocation with malloc and then reloc if you need to reallocate more memory. But that's ideally. Now it's not the ideal case. Then we have the readbeam file, the function, which essentially is gonna do a create file Windows API call against a specific path, and then this path is gonna be just a remote share. And since we can pass a remote share, the same Windows API is gonna be used as a read in a local file, and it's gonna work just like that. So the same API that reads local files can be used into reading files from remote shares. Nice, right? Then we can call read file, read the handle, and pretty much that's it. So here we need to also modify the size and paste it here. I think I need to do it better here. I can automate the whole thing, but I'm not gonna do it now. Oh, see how smooth that is. I can just scroll through the panes, which is so easy. Boom. Okay, I didn't know that. Thanks, Ubuntu. Okay. Now I cannot. Oh, there it is. There it is. Okay. There it is. Okay. And now here we use pretty much the same thing, virtual alloc, and we allocate the memory. We do a read bin, so we can read the file inside this buffer variable. Then we write this buffer variable to the memory and then execute it via direct pointer. If you don't know what direct pointer is, I highly recommend you guys read the blog post I've done a while ago, which explains what's a DP or direct pointer and why it's so OP. So I highly recommend to check this one out. Yeah. Now here we need to first make sure we have the SMB server and the right IP and the right share and the right path. So in our case that's gonna be output.bin. Then we have share and we have the IP of 185, at least I believe, yeah, it's 185. Now here we can do things like we need to set up the whole SMB server. So we can do in packet SMB server. It wants the share name and the share path. So we have share, the path is here. We have TS, debug for timestamps and debug messages, and of course SMB to support because it's super duper important. Run that. Now I guess we're fine, guys. I think we are now set up. So what that's gonna do is it's gonna first allocate memory, then do one request to our machine but via SMB and not via HTTP. It's gonna read the file, it's gonna allocate that into the buffer variable, where then it's gonna be written to the memory, executed, and the first callback is gonna come from here. So in our case, if that works, we're gonna do that. So first we're gonna read the payload, but this case from SMB. Let's do it like that via SMB. We're gonna read the payload is gonna be back, and then it's gonna be allocated, written to the memory, and then the callback is gonna come from executing the payload in memory. Why that's nice? Because now if we scan this file, I doubt something's gonna detect it. I highly doubt it. I can save and compile, and we can test that, guys. I can save and compile. Now we can go to the folder itself like that. Go here. Let's start Defender now, and let's scan the file. So turn on. Yeah, there it is. Now it's on. And now let's do scan. No trace found. That's the magic of staging. Whereas if I scan the previous file, because the payload is there, it's gonna be detected right off the bat. Trust me on that. So just because it's staged, we avoid the signature detections, which have no trace, and our file is generally behaving more stable. So I generally recommend staging by any means. Now we can try to execute it. Now Defender of course might block us on runtime because the app is a known payload, but let's just try it, right? I mean, we have to try it to know. So I can open CMDR, go to here and do stage.exe, even though the name is super suspicious. Now let me make sure the SMB is running. It is. I'm gonna go to callbacks tab and I'm gonna start it. Boom. And there it is. There it is. Defender is running, no threats are found, and that's how you bypass Defender with a simple SMB staging. Wow, and we also have the anti-LMD hash, which is super crazy. That's why I'm telling you guys to always go staging. That's the reason. I mean, this is not gonna be enough for complex CDRs and things like that, but as you can see, just one technique, just one set of technique was able to get our Apple beacon out of the Defender's way, and we bypassed it right off the bat. So we can now issue commands and work with it, we can do what, who am I, and things like that, and now enjoy our beacon. Oh, they also updated it. Nice. Okay, perfect. Where am I? And there it is. There it is. And the funny part is Defender is running. To be honest, I didn't expect that. I expected Defender to catch that on runtime because Apu is a known agent. But as you can see, staging is not to be underestimated. There it is. There it is. That's crazy. So that was the whole idea of the stream, to first test my system, how it behaves, and to showcase some practical things about staging and stageless. So the moral of the story is that when possible, always use payload staging. No matter if it's via SMB, if it's an HTTP via local file, or via anything else. Just avoid placing the payload directly into the file. Always stage it in some form by some third-party protocol or third-party solutions. So imagine the whole malware development part not as a single OP technique that bypasses all the vendors, but rather it's a set and combination of multiple techniques. Then when working together, that can make our payload evasive and effective. So now we can add maybe encryption to the payload. We can also do sandbox evasion, do a domain sandbox evasion and things like that, which can boost the evasiveness of the payload. But essentially the point is to add many techniques, combine them together, and test a lot. So with that, that's a practical Windows Defender bypass with Mythic C2. So I hope you enjoyed, guys, the video, and that was it. If you have any questions, you have just arrived, what technique did you use for bypassing Defender? Yeah, SMB staging. Just that. I didn't think that would work, to be honest. I expected some Defender to catch us in runtime when the payload is executed. But just that code, see how simple it is. I didn't do any DLL side loading, I didn't do anything crazy, just a simple exe with SMB staging. And the staging worked perfectly. So that's why I always say that this technique is my favorite for malware development, because it's super OP. Trust me, if you have the payload in the file, it's gonna be detected. So yeah, sorry for being late. You missed it, but I'm gonna post this to YouTube either way. So appreciate your time, and I hope you learned something new. If that's the case, always subscribe. Yeah. Thanks so much, and yeah, you can watch that on YouTube. So thanks so much for sticking by, and yeah, see you guys. Bye bye.